Welcome, everyone. We're here to start our fifth session of the Postgres Pulse series, which is a live interaction between us and you as the listeners and viewers. Our intent is to get out there and address questions and just active discussions around Postgres. This week, you've got myself, your host, Jamie Watt, as well as our moderator, Josh Heyer, led on the technical side by Vibhor Kumar and Bruce Momjian. Our subject this week was backups. You can certainly look toward the post that we released late last week, where we outlined a common question and a common problem that is presented to us from our customers, as well as what we see on both DBA Exchange, as well as Stack Overflow. How do I do my backups? It's a very generic question with a number of answers that are always specific to the environment that you have and the load which is required to support. As an example, how current do you need to be? What sort of resiliency do you need to have in the case of a failure? And whether or not it's more important to get back up and running or have the most current data. As we mentioned, it's a common challenge that a number of DBAs, as well as storage administrators and overall environment administrators face. And it's going to be different for almost every environment. So let's dive right into the questions. Josh, if you could share the first question that we've gotten.
Sure. This is Bruce's favorite intro to a question here. What is the best backup solution? He's got 2 terabytes of data. He's using the Citus Data CStore extension to enable compression and just a little bit more efficient access for analytics and the like. And he's using rsync to do backups. How's everybody feel about that?
I think it's probably a pretty big question to address. And it goes back to the fundamental statement that was made a moment ago. It's different for every environment. But there's probably a lot more detail to that I'm not going to do justice to. So Bruce, Vibhor, what are your thoughts on where one should start with even trying to have some sort of answer, whether or not this is a question that should be asked in the way that it's structured?
Yeah, we're all laughing at this one. You know, the reason this was I was so excited about this question was because it really is sort of approaching the problem from, okay, I've used rsync to backup file systems for years. I assume I should do the same thing with my database. How do I do it, right? So you're walking in with a set of tools, if all you have is a hammer, everything looks like a nail, right? So I'm walking in with this rsync tool, and I'm thinking, okay, how do I want to use this? But the good thing is the person realizes that maybe this is not exactly right, that there might be a mismatch here. And Vibhor, why don't you talk about the ways that rsync can mismatch for this type of solution?
So yeah, people use rsync to take the backup. Again, it's a file system level backup. You have to first put, again, if you follow procedure, you have to first put your database into backup mode, take the rsync, then stop the backup mode, and then you archive all the WAL files. But it's purely a cluster-wide backup. So if you want to recover a specific database, you have to first recover the whole cluster, then take out one database which you want to restore, right? And put it back where you want to restore, or in a cluster where you want to restore. So rsync method, people use it for taking a file system backup, and there are different mechanisms or different switches available in the rsync, which people can use to take the backup. I'm very happy that guy is talking about rsync. He's not literally talking about SCP or CP, because rsync is more atomic in nature. In the sense, when you're copying a file, either the whole file will be copied properly or it can fail. Plus, rsync also has the ability to start copying the file where it stopped due to some network issue, or if you're copying to a locally, somebody has pressed Control-C, rsync can take over that part, if you use a proper switch. So rsync is a nice solution For 2 terabyte of a database, it may be a very expensive solution too. So expensive in the sense it's going to create heavy load on the system, and plus when system and plus IO2, depending on multiple threads are you using, or are you using a one single process to back up the file system, it can be your system may actually become unresponsive for a while if you don't use it properly. So I think I'm not sure exactly what kind of a challenge the person is facing, Bruce. But yeah, I think if I recall correctly, Bruce, you have very well said once, whenever you're deciding any specific backup solution, you would have to step back, right? And try to think overall what you want to achieve. What's the recovery point objective, right? And based on that, you would like to drill down exactly what are the important scenarios you want to recover. Do you want to recover quick recovery of a table, specific table level recovery? Do you want to recover a corruption of the database? What kind of recovery you want to handle in that situation, right? So yeah, it's more like stepping back and thinking overall what area you want to cover or what area you want to resolve using this backup.
Yeah, because when I looked at this description, the first thing that stumped out at me was, as you said, if the server's still running, you can't just do an rsync. You have to also have all the write-ahead log records, because unlike a typical rsync file system backup where each file is kind of atomic, in Postgres, they all have to be synchronized. You can't just atomically grab backups of individual files and hope that they work, because they won't. So the way you have to do it, if the server's running, you have to back up, use rsync, but you also have to do PG start backup and go into our point in time recovery, go into backup archive mode. Okay. And then take the backup and then stop the backup and then grab all the write-ahead log files that you need to span the time that the rsync ran, right? If you're shutting down the database, then you can do an rsync and you would get a consistent backup. But again, this person is not really talking, he's not mentioning that at all. So that was the first thing, like they may be doing something that literally will not work as a backup. That's the first problem, that they might be doing something that in fact is giving them a corrupt backup and they don't even know it. So that's your first.
I want to tug on that for a second, because this seems like a common problem or a common approach to backups we see in questions and support requests, where folks are, the immediate problem they're focusing on is, how do I get the backup to run, and not how do I get a backup to run in a way that allows me to restore it when I need it. Right. That ties into the Pulse blog post too, right? Where you're talking about a successful backup that was completely useless for the scenario they were facing.
Yeah, the backup may be corrupt. Are they testing backups? I mean, these, you're getting into much larger questions. But the other, so the first question is, full stop, or is their backup actually valid? Because they haven't mentioned that they're shutting down the database before they do the rsync, which would work. They're not mentioning they're going into backup mode and grabbing write-ahead log files during the backup, which would work, right? So that's my first thing, is let's at least get them instructions which are going to give them a backup using the tools they've already chosen, right? But the second thing that they probably are missing is that a database has a continuous stream of changes recorded in the write-ahead log. And that's a facility that you do not normally have in a file system. Normally in a file system, you do a backup, you throw it away, you do an incremental backup, and you keep doing incrementals, and then you do another full one. But you don't have a facility typically when you've got hundreds of applications running all the time to get a stream of all the changes that have happened over a period of time. So you're having to do these atomic backups every night, every 6 hours, every week, whatever it is. And if anything changes from the first backup to the second backup, or the second backup to the third backup, you're kind of limited on what you can do, right? Somebody creates a record at 9 p.m. and they update it at 11, and then they delete it at 3, and they need the record from 9 a.m. Or there's a whole bunch of scenarios where that sort of point in time backup is really limited. And what they're not really understanding, I'm afraid, from the way the question's asked, is that the more logical place is, instead of doing either an rsync or a PG dump or some type of atomic one point at a time backup, typical enterprises who care about their data are going to be doing a base backup and then a continuous archiving going forward, so they can recover up until the truck comes in at 2 p.m. and crushes the server, right? They've got all their records up into a failure point at almost any arbitrary failure point they want to pick, right? And that's a facility that's unique to databases, and somebody coming from outside of databases is going to approach it like, I got the hammer, where's the nail, right? And they're not realizing that there's this incredibly complicated and useful capability of continuous archiving that they've probably never seen before in an application, that they really may need to rethink how they're looking at backups and say, okay, I now can do a much better job at backing up. I don't have to be running these huge 2 terabyte rsync job every night.
So I'm hearing two big takeaways here. You correct me if I'm wrong,
Yeah.
Bruce, but number one would be, define the kind of failure scenarios that you're wanting to protect against. Before you go jumping into a backup approach, you have to figure out what sorts of backups you're going to need or you think you might need. And number two, make yourself familiar with the capabilities of the tools that you're using, the system that you're using, because if you don't do that, you're going to go with a fairly clumsy approach.
Yeah, and I think that's the clumsy is the word I see here. That it can be made to work, but is this really using the best features of the database? Is it giving the person the full capabilities of what's possible in terms of data retention? The answer is no.
Yeah, and second, you can notice one more thing here. It's a 2 terabyte of a database, and the person hasn't mentioned about the growth of the database itself. Over the period, if your database is growing so fast, right, and whatever tool you picked up, right, may not be able to meet your backup time. So for example, you may have some maintenance window defined for 30 minutes. In 30 minutes, you want to make sure that your database is backed up, right? In that case, you would like to explore other opportunities or other possible use cases. So best example which I can give you is like in one of the biggest telecom company for which I was working, they had a 20 terabyte of database. And they were thinking to use PG-based backup, rsync, and all those solutions really doesn't work well with 20 terabyte of database. So we decided to use array level of the snapshots or the backups. And the best part was that they were using the HP array, which had the capability to take the incremental backups periodically and plus take the complete snapshot of the arrays. So that was very quick. So it's more like putting a database into a backup mode, start backup, and then taking the complete snapshot or incremental snapshot if you're going daily basis, or there is Sunday defined only for the complete snapshot, and then taking the snapshot of the whole archive wall files. So this is the way it was designed. And the 20 terabyte of a database backup, how much time it took, you can guess. It took like 18 minutes that time. So 20
was the database inaccessible during that time?
No, it was accessible. It was accessible. Everybody was using it. It's an online backup. That's why there's a start mode, there's a stop mode, and you make sure that you're archiving all the important wall files for the recovery. So think about that 20 terabyte of a database. If you can back it up in 18 minutes, that's pretty awesome performance, right? So yeah, this is the way you would like to explore your use cases. As Bruce mentioned, that you would like to step back, think about exactly what you want to achieve, what's the recovery point objective, and based on that, or what are the important scenarios you want to cover for the recovery, right? Using your backup. Based on that, make a decision.
Great.
Yeah.
All right, thanks, guys. That was pretty insightful, and I think this kind of tails pretty well into the next question that we'll pose. But in advance of posing that, I want to remind everyone: feel free to use the Q&A option that you have at the bottom of the screen here. Any questions you guys have, any conversations you want to bring forward, certainly feel free to pose it there, and we'll pull it in as we progress. And we appreciate any interaction that you guys bring forward. Okay, so if we could jump into the next question. This kind of, before we jump into this, one of the other options that any given Postgres user could have is it's not just about your PG-based backup or your incremental backup utilities. You could also be making use of replication and, let's say, a delayed replica as your solution. It all comes down to what the business can tolerate and what the tech provides for you. This particular individual is actually using streaming rep, but there's a hitch. So if we jump into this, the question that was posed was, they're using Postgres 11 on a Windows machine, and they're using it in a fairly inhospitable environment, and they're running it on a Win32 client from the application side, which has a lot of requirements around it, one of them being a CP1250 character set. They're asking whether or not they can reasonably have a streaming replication relationship on a remote server where the destination server is Ubuntu anything, but in this case it's 18.04 LTS running Postgres 11 on that side. So it's Postgres to Postgres, the same version. However, it looks like we've got some challenges or potholes in terms of both the operating system and the character set. What do you guys think of what they're considering here?
Well, first of all, if the target source and target operating system is not same, we don't recommend to do a streaming replication. So when I'm saying streaming replication, it means master and slave mode, where you have a read replica.
Yep.
But if you want to go with the logical decoding way of replicating the data from Windows to Ubuntu, then yeah, it will work, right? Because logical decoding supports different operating systems too. But I'm not sure which version is the person using. So it's very difficult to comment on that because logical decoding is fairly new feature in Postgres. It came in PostgreSQL 10.
Yeah, they're on 11, so they should be able to do that. Yeah. But do we see any issues around the character sets potentially?
Well, if you are using logical decoding, then you are safe. But if you're not using logical decoding, then there are a lot of problems, I would say. This is a kind of this reminds me of a situation when I was in one of our customers' environment, and I was just explaining them how they should use streaming replication. And the guy came up and said, hey, he tried using streaming the data from Windows machine to a one Linux machine. And we said, okay, how it works? We asked this question and he said, yeah, it's breaking, it's not working properly. Well, the reason was that there are multiple reasons. First of all, we found some issues around the indexes too, because the way index format and GCC libraries which got used in the Linux machine is way, way different from the Windows, right? So that may lead to a lot of corruption. And you can think about, there are some local support, right? Which is not very straightforward. There's a difference between these two operating systems you cannot get immediately. So yeah, you would like to make sure that source and target both of them have same operating system. It cannot be like you have a different operating system and you're just trying to replicate the data. But if you want to use logical decoding, that may be a possible solution for this person.
So, I mean, this is stepping back for a minute. This is a scenario you can imagine showing up all over the place. You've got effectively a data collection machine out on a factory floor someplace. It's pulling in heavy amounts of data from different sensors or whatever, and storing it in this database, but the environment itself is not conducive to long-term reliability. So they're trying to just make sure that they have a backup in case the machine itself fails, right? He's able to import this backup. He's not able to use it on this machine. How confident would you be in just using this strictly as a backup, never actually running queries against it, never actually trying to interpret the data that's being stored in clearly an unsupported locale?
I mean, I think you got a couple things, you know, and this is part of the Postgres architecture, that the same write-ahead log, that same change log we just talked about in the rsync case, is basically the exact that change log that we would use to do crash recovery to make sure that if the system crashes, any committed transactions are preserved. That same change log is used for point in time recovery, continuous archiving, which is what we talked about the rsync case. Okay. That same change log is used for replication, right? So it assumes as it's replaying the replication log or crash recovery or point in time recovery, it assumes that the character interpretation is the same. It assumes the ordering of the characters is the same. Those are probably your two cases you're going to foul up here. One, you're going to store characters the system, receiving system can't interpret because they don't, an A with an accent is not an A with an accent in each encoding. But then also you're going to have indexes, which are going to have ordering requirements, which are going to be different. You're also assuming the compiler is going to align the data the same, that you got in the same CPU architecture. I mean, there's a whole bunch of things here that you're assuming that are going to work between these two architectures. And I would have
So
no
even
trouble.
though it looks like it's working, they may end up just having garbage in their database.
You may do a query that accesses an index, and the index doesn't return the same rows
Correct.
as it would on the first machine, right? That's like a silent case. You could get just garbage back. So you're looking at the characters and you're like, that's not a Hungarian letter anymore, right? That's something else. So yeah, Postgres will detect most of these cases. It's not so great at detecting if the encoding's the same, but the ordering has changed between the two implementations. And that's kind of where that ICU library versioning comes in.
Well, it
But yeah,
looks like he's getting an error here trying to connect with PSQL, but I'm guessing that might show up if he tried to just restore it to the original database as well.
like he could probably try and get an encoding that worked. Like he could just go straight flat ASCII and then it might like start. But again, would you get the same results all the time? That's the problem because you have so much dependency, not only on the CPU, but also on the encoding libraries, the collation libraries, all the localization stuff. Postgres is typically going to use the operating system's facilities there. And obviously Ubuntu and the CP 1290, I think, or 1250, which is not a UTF-8 encoding at all, as far as I know, are really not going to matter. Now, Postgres will convert from a client using, and this, they didn't even really get into this, Postgres can convert a client running an encoding into UTF-8, okay?
So a possibility here
on the
would
server
have possibly been to change, instead of storing it in Hungarian 1250, they could have stored it in UTF-8.
Right, they could have had the client still at CP, and the beauty is the client will always see the data in that encoding, right? But the server could use UTF-8, and then you may be able to then get Ubuntu. Ubuntu would certainly understand UTF-8, okay? The concern I would have is the localization version, the collation of Unicode, the same behavior for the characters they care about between the two, because Unicode does change its ordering once in a while in terms of, we get updates. Okay, Germany doesn't want these letters together anymore, or they want this letter to appear. So that's where you get into the really niggly problems.
So that'd be something they could think about, depending on their use. And again, I'm guessing this is very likely just a data collection system. But if they are running queries against it and are using that, from the server machine here, that might be an issue. Now, our asker here says they went and purchased a Windows computer in order to back this up, but they're still kind of curious about what other options they might have had. So that could have been one. Having the ability to change the server itself, how that data was stored, might have solved this problem.
Yeah.
Or running a
What
Windows
other options
on
would
the
you have?
Ubuntu side, right? They
Yeah,
could just
so
simply be running a VM, take the simplest approach to it.
Yeah. And
Okay.
also, I'm not even sure logical replication would help here, because it's possible the two tables are in different encodings. So logical replication would handle the problem of ordering of the records. So the ordering of the records would have been fixed. But the problem, if the data is stored in one locale, it's not automatically going to convert it to whatever other locale you have there. You have to, both tables have to be using the same collation when you create the two. Logical replication, you're going to have to put collation for those tables in each row or whatever column, and those are going to have to match, because if they don't, you're still not going to get the right conversion going on.
Got
yeah,
it.
but still you can consume the data from the target side, because logical decoding actually happens at the source side, and it just only streams the SQL or the format, the values
The rows, yeah.
storing into the table. So yeah, even if you have a UTF-8 on the target side and source side, you don't have a UTF-8, but your application can work on both the encoding and you will be good, right? So yeah,
Okay.
This is why we
So there's
recommend
a lot of it
UTF-8.
depends, right?
Yeah.
yeah,
This is why we basically tell people, unless you're absolutely sure you're only getting Hungarian in there, you probably just want to go UTF-8, because then
correct.
whatever comes in, whatever data gets in there, it's going to be in some kind of uniform format.
Mhm.
So that's typically why we're pushing people away from the country specific encodings and locales for that reason.
Well, I think we had a couple possible ideas, but a lot of these are it depends based off of what we see as far as locale handling, as well as whether or not they could potentially even be running a Windows VM on the Ubuntu side.
Yeah.
But it comes back to the overarching theme, right? You've got to make sure that you're doing something that is going to work, and not drawing a web of assumptions simply because it appears as though it's working.
Mm-hmm.
Okay, great. At this point, I want to pause for a second and again mention to the audience, if you guys have any questions, certainly feel free to raise your hand and pose them in the Q&A. We're running down to the last few minutes, and I want to make sure that anyone who does have a question has an opportunity to pose it.
And let me just add that we are nearing beta 1 for Postgres 13. That will be on May 21st, we currently believe. I am working on the major release notes. The downside, or the bad news, is there are not a huge number of new features coming in 13. I am working on the release notes. I kind of cobbled together what I think is a short major list of features, and there's really no big banner thing coming in this release.
And that's probably not a consequence of big bang things being worked on, maybe more just a matter of them being reasonable for V13. Would that be a fair assumption?
I'm really scratching my head on this. It's certainly not related to the COVID virus, because
Right.
obviously we work from July up to now. I don't know what it is.
This is where you say the database is just too good already.
Yeah, we just don't have anything to add. Yeah, we've hit perfection.
Okay. Well, I think we've got time for a real quick last one. It was a fairly straightforward question, if we want to throw that up there.
Yeah, this one seems like something that you've already touched on a lot of aspects.
So the question is, as a developer, he's using Postgres. If he's got 20 databases inside a cluster, and he's got a need where he has to roll back just a specific database in that cluster or on that server, is that possible with out-of-the-box backup capability?
And Vibor, I think you talked about this already.
Yeah, I already talked about this. So yeah, so it's not possible right now, because I'm assuming he's talking about the file system level backups, which we support.
Yep.
Online backup or physical backup, in other words. So in physical backups, you cannot store one specific database. You would like to first store the whole cluster, and then take out a specific database which you want to restore into some other location. That's the quickest way you can do that. But let's say if your recovery point objective is as fast as possible, then create a one standby, and I would say delete standby from the primary, and make sure that you can recover, meet your recovery point objective. Again, in that case also, replica will be behind the master, and there will be some window you can keep it like an hour behind or 2 hours behind. And based on that, you can use pagedump and restore back it into the in the location where you want to recover your database.
Yeah, I
So
think we touched on that in this past week's blog as well.
Yeah,
Yeah. So PG
Okay.
dump is really the only per backup
Correct.
per database option we have. Yeah.
yeah.
Which is not a bad option. It just you know.
Yeah, but if this doesn't work well with you, then the person can actually look for some other strategies. He can create multiple clusters of the PostgreSQL and put each database into those clusters, right?
Right.
And run those in parallel. So this way he will have a database level recovery from his point of view, but it will still be a cluster recovery.
It'll be minute and fine-grained enough that he gets what he needs out of it.
Correct.
Okay.
Correct.
All right, great. Well, thanks, guys. Another great session, a lot of good questions posed, and I think we kind of touched across a number of different do's and don'ts with backups. For those of you in the audience, if you guys have questions, again, feel free to post them either with the hashtag PostgresPulse on LinkedIn or Twitter. You can also reach us at postgrespulse@enterprisedb.com, and certainly you can feel free to post them live. We'll be back again next Monday at 11 a.m. Eastern Time, and thanks everyone for your time. And thanks to Vibor and Bruce for the discussions today. I think they were great. Thanks, Josh, and thanks, everyone.
Thank you.
So long.